So this is Honors Algebra 2 Pre-Calc. We're doing 6.3 in Pre-Calculus. This is example 11, which is finding a directional angle of vectors when the vectors are not something, when the angle is not something you're going to find in the unit circle. So I'm ruling out all of those 45s and 30s and 60s and nice happy things. So my directional angle, right, is going to be, theta is going to be the inverse tangent of the y on top of the x, right? So negative 0.5. So I'm going to put that on my calculator right now. Oh, before I do that, though, it's worth noting you should know which quadrant you're in. So if your x's are positive and your y's are negative, then this information communicates that I am definitely in quadrant 4, right? And so it's worth noting, oh, hey, wherever my vector is, right, I'm over here. I'm in quadrant 4. Right? The reason that's relevant is that the angle I get out, I need to make sure that that's a logical, sensible angle based on being in quadrant 4. So if I go ahead and do second tangent, right, I'm already in degree mode, of negative 0.5, right, or negative 1 divided by 2, I don't care which, I may get that that's a negative 26.565, right? So the thing is that it's giving me this answer, which is a negative 26.565, and that's not wrong, but it's typical that we're going to write it as the positive equivalent of that angle, right? So to find that, to get the coterminal angle that would be the exact same spot, I'm going to take this number and I'm going to add it to the full circle to get the coterminal angle that would be the same spot. And that is going to be a 360 plus that number, so I get that my theta is a 333.43, either 4 or 4 or 5, depending on if you truncate or if you round using that 9 in degrees, and because I rounded and truncated, I should put an approximate, so that's my theta, right? When I look at B, now I'm in quadrant 3. The reason I know that is that negative is quadrant 3, right? Negative 3, negative 4 is going to be somewhere over here, right? That's my U. So I'm definitely in quadrant 3, which means that the angles I'm going to get as an answer, I want an answer that's somewhere between a 180 and a 270, right? Because that's where quadrant 3 lives if we're in degrees. So I'm going to go ahead and do my theta equals the inverse tangent of negative 4 over negative 3, but what's going to happen is I'm going to get an answer that's in quadrant 1, and we're going to have to use some logic. So I'm going to do second tangent, which gives me inverse tangent, of a negative 4 divided by negative 3, and I'm going to get an answer that is approximately a 53.130, blah, 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 degrees. Here's the problem. That angle is right here. I don't want that angle, right? Because I'm definitely not in quadrant 1. I don't want a number between 0 and 90. I want this angle. So what I want you to notice is that this angle is exactly 180 degrees off from the angle that I just found. So if I say, hey, I get it, I have to add a full line to get to the angle I actually want, I'm going to get that theta is approximately, and I'm just going to take this and hit plus 180, right? And then hit enter, and I'm going to get that theta is approximately 233.130 degrees, which is definitely in that window of quadrant 3 from 180 to 270, right? So we just want to keep in mind what quadrant we should be landing in. So that's how we find directional angles.